Let me know once it is visible to you.
Yes, that's
okay.
visible.
All right. Today is the first class, so I'll start with some of the basics that you guys have already learned in your CCNA course or in your studies also. Can someone explain me or help me understand what is a collision domain and what is a broadcast domain, and how do they differ? You can take as an example of hub or switch or a router.
So Gaurav, what I understand by collision domain is, so hub will have only one collision domain. So if a hub is transmitting the data, so maybe if it's sending, the receiver will have to wait, or the other devices will have to wait, or there will be a collision. And switch will break down, each port will break down one collision domain. So if one port, if a device connected to one port is sending the data, it won't impact the data sent by another port. And routers will break out broadcast domain. So broadcast domain is nothing but if a broadcast is sent, all the devices in that particular domain will receive the data.
All right, that's very good what you have explained. Okay, so I'll just repeat. So within hub, everybody knows that it is kind of CSMA-CD, carrier sense multi-access collision detection mechanism. Okay, so within hub, let's say we have 8-port hub. So at a time, only data either can be transmitted or received. If one port, on one port, we are sending a data or we are receiving a data, it is going to be broadcasted onto all other ports. That's how hub works. And it is also known as half duplex mode. I mean, either transmit or receive. So all the ports within our hub are in a single collision domain. That's why we say that either you can transmit or you can receive. And at a time, only one person can either transmit or receive, right? And also, I mean, within a hub, how many collision domains we have? Only one collision domain. Okay. Similarly, all the ports within a hub are also in a single broadcast domain. BD. Right? Agreed. Similarly, within a switch, how it is, I mean, how what is better that we got in a switch is each port on a switch can independently transmit or receive data. Okay, so each port can work in a full duplex mode. So that's why each port is having its own collision domain, right? If I talk about a broadcast domain, by default, a switch is a single broadcast domain by default. Okay, when we talk about VLANs, then we will talk about multiple broadcast domains, right? Router, yes, each port is having its own collision domain as well as broadcast domains, right? Any question or any doubt in these concepts from anyone? All right.
Gaurav, then if we are in a same network, then it will be the collision domain. Otherwise, it will be the broadcast. If we have a different domain, then it will be the broadcast domain, right?
No, wait. For example, in we all are joined in a Zoom meeting, right? Okay. Yes. If I am transmitting anything, if I'm saying anything, and you at the same moment, can you also talk? Will it work?
Yes. Yes.
I mean, you can talk, but our packets or nobody will be able to listen anything what I said or what you said.
Mm-hmm.
Do you agree?
Yes.
Okay, so that's why we can give an analogy that we all are connected to a hub. At a time, only one person can talk. We all are in a single collision domain and a single broadcast domain. If I am saying anything, everybody on this Teams group or Zoom meeting, everybody can listen or receive that data. So we all are in a single collision domain and a single broadcast domain.
Yes.
Okay, this analogy is fine. Now,
Yes, understood.
if I talk about a switch, so in switch, let's say you are talking directly to me. Okay, we both are talking, or let's say how shall I give an analogy? Let's say in a mobile communication, how it happens. So in a this is a switch, and your mobile, okay, have connected a call to this mobile. So you both are talking. Let's say this recipient 1 and 2, they are talking to each other. Similarly, there can be another host, let's say mobile 3, which is talking to mobile 4. They also can talk to each other. But can the communication which is happening between 1 and 2, 3 and 4 can interfere? No, they cannot.
Yeah.
I mean, okay, so they are in a separate broadcast domain and a separate collision domain also. Okay. Similarly, a router, what it does is, for example, in switch 1 and 2, let's say they were in the same VLAN. So what data 1 is sending, okay, it is being broadcasted till 2 also. And if let's say 3 and 4 are also in the same VLAN, that data could have been broadcasted to here also. But 3 at the first go itself, 3 would have said that, okay, this is not meant for me. The destination address within this packet is not mine, so do not send it to me. However, similarly in router also, each port is having its own collision domain as well as its own broadcast domain. Router does not pass your broadcasted packets. If I send a broadcast onto this port, it will not be passed on to the next port. It will be broken over here. So that's why when we say, I mean, where to use a switch and where to use a router. If we are, if we want to communicate within a single within a broadcast domain or a single broadcast domain, you can also call it as a single subnet.
Yes.
Or subnet. Then it is using a switch. If we want to talk inter subnet or inter VLAN communication, then we need a layer 3 device. Can it be a router? Can it be a layer 3 switch?
Yes. Understood.
Right? Okay. That's good. Let's move to our
Garo, so switch using always in the LAN, yes, and router always use in the WAN.
Say again, please.
So switch is always using in the LAN, yes.
For LAN communication, yes.
LAN communication, and
Local
router
area
is using always the WAN for WAN.
Primarily for WAN communication.
Yeah.
But it will be ideal to say that inter subnet communication is done via a layer 3 device using a router.
Yeah.
However, switches also we have layer 3 kind of switches who can work like a router.
Yeah.
We'll go through it. Huh? Let's move on to our topic. Okay. So within a switch, for example, traditionally our LANs were made of Ethernet hubs. Okay. Nowadays, those hubs have been changed with a switch. So in a hub, we have already seen that all the hosts share the available bandwidth of a hub. Okay. And it forces the devices to either listen or send the data. That means hub can only work in a half duplex mode. Now, if two hosts send the data at same time, that collision will occur because why collision will occur? Because all the ports within a hub are in a single collision domain. As like we all are in a single Zoom meeting, only one of us can talk at a time. Right? Now, within a switch, how it happens? Switch is, we can call it as an intelligent hub. Why intelligent? Because it is having, it keeps some data like which host is connected to which port. How it keeps that intelligence is using the MAC table or a CAM table. CAM table is or MAC table is one and the same thing. We call it as a content addressable memory. Okay, so let's say this is a switch. It is having 6 different ports. Okay, on port 1, it received a frame which is having a destination of, let's say, this is a hypothetical MAC address. Okay, 5555. So switch can decide where should I forward this frame. Initially, if when it does not know, or let us assume that its CAM table or MAC table is populated as like this. So how will it see is, okay, it sees that my destination address is 55555. So where I need to forward this frame to? Port number 5. Do you agree? Okay. If then it will send that frame to port number 5. Otherwise, let's say a frame comes to it and the destination address was not at all listed within its MAC table. So what it will do is, it will send a unknown broadcast. Okay, that frame will be broadcasted to all the ports to check within that VLAN. Basically, VLAN concept will cover, but first let us understand that frame came, but it does not have that MAC address within its CAM table. So that frame will be broadcasted. Okay, let's now see. For example, this is our topology. We have from this switch, we have on 3 ports, we have connected host A, host B, host C. Okay, all these are having, let's say, their MAC addresses is AAA, BBB, and CCC, and these are their respective IP addresses. So as of now, all the switches, all those ports are admin down. Okay, and this host network card is also down. Let's say by when we unshut the port on the switch, all the 3 ports, let's say we have unshut. Okay, they are now up, and host A, let's say we power on this host A. What will happen first? So what happens is,
it will broadcast.
Yeah. So what happens is, you guys must be knowing, what it will send is, it will send a GR request.
Packet.
No, not a hello packet. It is known as
Yeah.
gracious ARP.
Yeah.
Okay. So what it does is, within a gracious ARP, it sends its own IP address, okay, and its own MAC address as a source. Source MAC, this one. Source IP, this one. What is the destination IP of that packet? Can anybody tell me what is the destination IP in the GR packet?
It will be the FFF.
No, destination IP is
Oh, sorry.
itself only, same IP. And the destination MAC is FFF. You are right. That is our broadcast MAC. Okay, so GAR packet is sent. What will the switch do is, switch will learn its MAC address on port number 1. So what it will do is, it will basically, this GR packet is to check the duplicacy of this IP address, whether anybody
Gaurav,
else is.
Gaurav, yeah, Pawan here. GRP is something, it's a gratitude ARP, right?
Correct. Gracious ARP, yeah.
Yeah. It's like after reading the MAC address, it sends the acknowledgement. Is that the GRP?
No.
Yeah.
GRP is to check the duplicacy of IP address. I have assigned this IP address, so it will check whether anybody else is having the same IP address or not. If not, then it will initialize as a legitimate address over here. So because of this GR request, switch will populate its MAC table. Okay, here MAC AAA will be learned on port number 1. We are assuming all the switch ports are in a default VLAN. Default VLAN is VLAN 1. Similarly, same thing happens on host B and host C also. Okay, this B MAC will be learned on port number 2. in VLAN 1. VLAN 1, port number 3, switch will learn this thing. Do you guys agree? Anyone having any question?
I'm
No.
clear, Gaurav.
Okay,
Yes, okay, fine.
right. So let's move further. We'll see that in lab also, but before this, let's cover this one also. This is talking about, let's say these two hosts are now in a different VLAN.
Gaurav,
Yes, say again.
Gaurav, I have a question.
Yeah, tell me.
Gaurav, as you told us the CAM, content address memory.
Yes.
Okay, so what is the difference CAM and TCAM?
We'll cover that. We'll cover that, and just hold on for a moment. A couple of slides later, we will be covering that. Huh? Can you guys go on mute if you're not talking? Okay, thank you. So in here, the scenario is we have two hosts, host A and host B, but the difference is that earlier host A and host B were in the same VLAN, but now we are considering them in a different VLAN. Let's say now this is in a VLAN, let's say 10, or on the green side, it's in a different VLAN, VLAN 20. That's why their IP addresses or subnets are different. I'm assuming that you guys all are aware about subnetting, or I mean, how IP subnetting works. But
Yes.
still,
Yes.
we would. I can take the questions if you have any. Okay, but I'm assuming as of now. So now, if let's say the same thing will happen on this switch 1 or on this switch, CAM table will be populated using GR. Okay, and they'll switch will be having on port. Let's say this is port 1. Let me take the marker. This is, let's say, port 1, and this is port 2. On port 1, it has learned that MAC AAA is connected, and port 2, but this is in a VLAN, let's say VLAN 10. Okay, and this is in VLAN 20. So a slide before, we have already seen that in our MAC table, there is a column for VLAN also. So against port 1, VLAN 10, we have a MAC address AAA, and against port 2 in VLAN 20, we have a MAC address BBB. So once a packet will come from here, host A wants to communicate to host B. Okay, so IP, this is my source IP, this one. My destination IP is 11.1.1.2. My source MAC is AAA. What should be my destination MAC, and why it is FFF? Can anybody tell me? FFF, I am assuming that this is a MAC of this layer 3 port, not a broadcast IP.
Here's the connecting port you have from the source. That
We don't
has,
know the destination.
Because it is not known to the sender.
No, we don't
Right.
know the receiver MAC address, so we are searching for the MAC address. We are broadcasting the packet to all connected ports.
So what will happen is this host A will check that, okay, this destination IP, does it lie in the same subnet for which I am also having an IP? No, it is outside my subnet. So what I shall do is I'll have to forward all these packets, irrespective of anything, to my default gateway. My default gateway is this one. Okay, let's assume this one is 254. Okay, so I'll have to send all the data to my default gateway. Now, to send an Ethernet frame to my default gateway, I should have.
Sir, but switches do not perform interval routing.
No, switch, I'm assuming this is a layer 3 switch. It is having layer 3 gateway configured.
Okay.
So it will perform. Okay. So what I want to do is I want to send all my data to my layer 3 gateway. So in order to send the Ethernet frame, or in order to form a Ethernet frame, I should have a destination MAC of my default gateway. So I'll send an ARP of this one, my default gateway. This will respond to me with this on MAC address. That's how this frame will be formed. Okay. Once this packet reaches over this switch, it will decapsulate this packet. This source MAC will be removed. This destination MAC will be removed. It will decapsulate that packet and see the IP stuff. Within IP, what it is having on this switch I'm talking about. On this switch, it will see a source IP, this one, destination IP, this one. Since it is a layer 3 switch, it will check its routing table. Where can I find this destination IP? So within its routing table, it will be able to find that, okay, this IP is within this subnet, which is connected to my this port number 2. So what it will do is, it will send another ARP request over here to have the MAC address of against this IP address. Okay, another ARP will be sent over here. It will respond with its own MAC address. Then a frame will be formed with the source MAC. What will be the source MAC now?
Which MAC?
This MAC, triple G.
Yeah.
Okay. Well, what will be my destination MAC?
BBB.
BBB. Source IP?
The L3 switch IP.
No. Source
No.
IP
So,
will not
host
change.
IP. Yeah, right.
Source IP will not change. Or
10.1.1.1.
Yeah, 10.1.1.1. Destination IP?
Destination MAC.
11.1.1.2.
11.1.1.2. That will also not change. So for what we have seen over here, in each network segment, we can say our MACs are changing. Our IP is not changing. Our source IP or destination IP remained same, but our MACs are changing. All right. Any questions over here?
Gaurav,
Good for me.
hello.
Yes.
Gaurav, why it's changing the source MAC?
Okay. Source MAC, why it is changing? Because this MAC is relevant or it is known within a segment only. Here my layer 3 segment is being changed. This MAC is what I would say is within this VLAN or within this broadcast domain, this MAC is known.
So MAC change each hop?
Not each hop, at each L3 segment. This is one L3 domain layer 3 segment. This is another layer 3 segment. That's why your MAC is changing.
Okay. Not clear. Thank you.
Okay. So somebody asked me that what is the difference? Can you guys please go on mute?
Yes. I'm here. I asked.
Please put yourself
Sir,
on
I
mute.
have a small suggestion. While you are taking class, please switch off the mute or mute the others. And since you are asking the questions last, they can ask their doubts, right?
Yeah, great. It will be great, Gaurav.
Can I put you guys on mute? I have control.
Sir,
Okay, I have.
Yeah, there is an option of mute on.
Okay, I can do now. Okay, done it. Thank you, man. So within okay, we were talking about CAM and TCAM. So CAM, we have already learned. CAM is nothing but it's a MAC table wherein we are storing our MAC against a port, against a VLAN. However, apart from this CAM, we may have certain ACL entries, certain QoS stuff, or routing tables where we will store them that are stored in a tertiary CAM or a TCAM. Okay, TCAM, as the name suggests, it says a tertiary CAM, okay, or ternary CAM. So when we are matching a MAC, it should be matched completely. I mean, within our, if I show you, wait, So here, while we are matching this source MAC or a destination MAC, this complete MAC should match what is there in our CAM table. However, when we are matching an ACL entry, do we need to match complete source address? For example, 192.168.0.0 we have. Let's say this one. And if I come over here, so how do we have in our ACL entry? Let's say we have ACL, you all know, huh? Access list 10 permitted. Okay, what this entry says? This entry says that I need to match only first 8 bits. The rest all I can ignore. They can be anything. Okay, so what I'm matching is either 0 or 1. Oh, sorry. Either 0 or 1, or I have a third option also. Do not match at all. Right? In binary format, within my table where I'm storing these ACL entries, I'm matching like match this first bit as 1, second bit as 0. However, for these things, I have masked them. I do not want to match them at all. So that's why there are 3 probable entries. Okay, so that's why this ternary CAM is known as, this is known as ternary CAM, wherein we can have our ACLs stored, we can have our routing table stored. Within your routing table also, how we have, let's say a static route I have, IP route, let's say 192.168.10.0. Okay, and I have given like this, and my gateway I'll specify, let's say 20.10. So what I'm saying is, for all the IP addresses destinations, I'm only matching first 3 octets or first 24 bits. They should be same as like over here. However, I do not want to match my 4th octet. Then they will be routed towards this gateway. Okay, so that's where this TCAM comes into picture, wherein we are storing our ACL entries, we are storing our QoS information or our routing tables. Okay, any questions?
No, Gaurav, thank you.
Sorry, I could not hear anything. Hello? Any questions somebody had?
Hello.
Yes.
So TCAM, it is only available in L3 switches or both L3 and L2 switches?
TCAM is generally for my L3 stuff to store. So we can assume that this is there in our routers, this is there in our L3 switches.
Okay, so L2 won't come in this picture when it comes to TCAM, right?
Yeah.
Okay, thanks.
Okay, let's see the same stuff on our so let me power on these 3 things. Eve, everybody know about this Eve emulator?
Yes, sir.
Yes, even G.
Okay, all right. So herein what I have done is I have taken a layer 2 switch. Okay, 2 VPCS host I have connected. one on port 1, one on port 2. Okay, let me shut down the rest of the port so as to make it clear. Interface range is 0 by 2, 3. Shut. To show interface status, what it is showing is, it is showing me all the ports within our switch, their status, whether they are connected, disabled, or whatever they are. What are their VLANs, their duplex mode. A stands for automatic. I have not configured any duplex mode. Let's say show run interface E0 by 0. So by default, it's an automatic mode. I have not configured the duplex over here. So that's why it is saying automatic, but after synchronizing, it has been operational status is in the full mode. Speed is auto, RJ45 connection. So if I check my CAM table or MAC table over here, show MAC address table, it is empty as of now, right? Let's say I log into this host 1 and I configure 10.0.0.1/24. See, it is checking for duplicate IP address. So duplicate address means it is sending that GR request. Okay, and because of that GR, my switch should be having the MAC table learned now. So this MAC address is coming from this host 1. Okay, same way, if I should have some capture also. If we see, let's do on E0 by 1. So we are capturing the traffic what is coming on E0 by 2. Okay, let's do the same thing on port host 2 also. IP 10.0.2/24. Let's see this one. Did I choose port 2 or port 1? I think I chose wrong port. E0 by 2. Host 2, let's say reboot. I just wanted to show you that GR packets. Let's try over here. Okay. Let's try on this E0 by 1 itself. I'll change the IP address of what is given to this host. Let's say I made this 10. See, it sends a R packet over here, which is gracious R. In gracious R, it's a source Ethernet address, its own MAC address. Destination is a broadcast one. Okay. However, my sender IP address is same. sender and the target IP address. They are same. This is just to check the duplicacy of the IP address. And because of that, switch is learning its putting that IP address within its MAC, learning the MAC address in its CAM table. Okay, same thing. I mean, what we can do is this MAC address is usually it is burnt in address. I mean, we cannot change this address. So in order to keep it secure, let's say we want that this MAC address should be learned from this particular port only. On any other port this should not be spoofed. So what we can do is we can configure a static MAC address also. We'll cover that thing in our next one also. Or let's say I configure over here as MAC address table static, and I put the same MAC over here. 866.5. As of now, you can see that what is the type of this MAC address? This is being learned dynamically. So there is a default timer also, after which this will, when that timer is expired, this will be flushed out of over here. Okay. So if I want that this should remain within this table, I can statically define this MAC address against this port. Let's say I configure VLAN 1 and interface as Ethernet 0x1. So now if I check my MAC address table, see, now it has been statically configured over here. This will not be aged out. I can see that aging timer also.
So if we will configure the static MAC address, so it will be not spoofed, yeah?
Yes, it will not be. I mean, it will not be aged out. First thing is that. Okay. Otherwise, what will happen is the first packet will go. Will get dropped because of this ARP resolution only. MAC address learning. Otherwise this switch will drop the first packet. So if we do not want that packet to be dropped, we want that this to be statically present always within my MAC table. We can statically configure it. Generally, why we do this is, for example, on any switch port, my firewall is connected. Okay, and I do not want that every time switch should send a ARP request or a layer 3 packet before sending a layer 3 legitimate packet towards firewall. It should not send an ARP packet. We can statically configure the MAC address of the firewall port onto that switch port, because we know that this is always being connected over here.
Clear.
Okay.
I have Pawan here. I have one more question.
Yes, Pawan.
It's like troubleshooting. Sometimes that interface is not with the MAC address. What might be the issues? I mean, what might be the possible causes for that?
I'm sorry, I didn't get your question. Say again, please.
Sometimes the device is connected to the that port,
Okay.
so that Ethernet one, and the MAC address is not learning for that port. Now we have configured the static MAC address. That is fine. But then the device is connected, but the MAC address is not learning. So
Okay.
what will be the issues in that case?
Try to understand like this: how we are learning this MAC, how the switch is learning this MAC from this host. First thing is that dynamically, this host should respond to some query. For example, as of now, this learned MAC via GRP request, which host has sent. Otherwise, let's say these hosts were in a different VLAN and host 1 wants to send a packet towards this host 2. So host 1 is sending a ARP request towards host 2, and host 2 should respond to that ARP request. Okay, then only that MAC will be learned.
No. What I'm asking is, suppose host 1 connected to the switch port Ethernet 1. So Ethernet 1 itself is not learning the MAC address. It's not showing any MAC CAM table in that. That MAC is not showing in the CAM table.
I got your point. switch is not showing any MAC learned over Ethernet 0x1. So there can be multiple things, but usually what it happens is this host itself is not able to respond to the queries which switch is generating.
So
because
it
it is being dynamically,
because
it is being dynamically learned, this host has to send its MAC towards switch. Nobody else is sending.
Okay, so that might be the issue with the client. I mean that host one, or is there any possibility that like cable issue or any port issues, that kind of physical
Generally,
issues also?
yeah, I would say cable issues could be anything, maybe half duplex or full duplex stuff. However, this MAC is being learned over an application. Application means ARP is acting as an application over here. When it is not responding to ARP request, or somebody is prohibiting it to send a reply, it is receiving a ARP request, but somebody is prohibiting to send the ARP response. So that's where it will not be able to learn that.
Okay, good.
Okay. So I'll stop this one. Okay, I'll bring this down. Let's move back to our slides. So this one we have covered. Show MAC address table is a command to see the MAC address table contents. Okay, this MAC address table, as we said, that it is having MAC interface or the port as well as the VLAN. So it can be filtered based upon the interface or a VLAN also. Aging time is by default 300 seconds, that is 5 minutes. That is a default aging time in our Cisco. It can be modified using this command, MAC address table aging timeout, and then you can give this command number. Okay, static MAC address also we can configure against a VLAN and an interface. Right, now let's move to concept of VLANs. Okay, what is this? Annotation is coming. Stop share and reshare. You can see my screen, right?
Yeah, right.
Okay. So we have already seen. So see, for example, this is one of the diagram wherein this is an office LAN, consider it as, and for each department, let's say we are using a separate switch for management, separate switch for help desk, separate switch for finance, security. I mean, physically they are separated. However, they are all connected together like this. So do you see any challenge over here?
Unnecessary switches are using.
Okay, yeah, very good. Unnecessary port or infra is being there. Okay, what else?
And traffic will be flooded to everyone.
Say again.
The traffic will be flooded to everyone.
Okay, lot of broadcast, flooding.
No,
very good.
Security problem.
Security
And
problem is the third one.
And cost also.
Cost will also go high because a lot of infra is being wasted. Very nice. Most of the points have been covered over here. So what we should do is, how shall we keep our network secure, reduce the broadcast, reduce the cost, less infra?
Using VLAN.
Very good, very good. Okay, so what VLAN is bringing to the table is, VLAN is a kind of virtual LAN. Okay, it is segregating our network into different broadcast domain. That's how we are able to keep them, reduce our broadcast and restrict that into a single VLAN, that is virtual only. Okay, we can keep them separate as a logical subnets or a layer 3 subnet. We are doing the segmentation. Okay, we are making it secure and increasing the flexibility of our domain. So within this, earlier, let's say we were having multiple switches. Now what we can have is, we can keep our layer 2 switches with respect to floors. On the same floor, I'm having multiple departments who are working, but their respective laptops or desktops have been configured in a separate VLANs. Okay, so these VLANs are bringing a separate broadcast domain. Each VLAN is having its own IP subnet or own broadcast domain. All right. So as we have already gone through, these are some of the advantages. We are dividing our broadcast domain. We are limiting our communication or making them secure. Rather than grouping them physically, we are grouping them logically now. All right. Types of VLANs. So on a high level, I mean, we have standard VLANs, extended, and within that extended, we have some internal VLANs also. Standard VLAN range is starting from VLAN 1 going to VLAN 1005. This is the number. Okay, VLAN 1 is our default VLAN. Every switch port within our switch is by default part of VLAN 1. Okay, and our default native VLAN, okay, this one we will cover in next topic also, trunking. Default native VLAN is also VLAN 1. This VLAN cannot be deleted, but can be manually pruned from our trunk links. I do not want to pass traffic between two switches over VLAN 1, then that can be pruned. Okay, VTP is VLAN trunking protocol. Using that, it cannot be pruned. So what is VTP? Just I'll give you a brief. For example, I have 50 switches in my LAN network. So this will not be a good idea, let's say, and I want to configure 10 different VLANs. So on each switch, I shall log in and configure all those VLANs. Rather, if there is any mechanism wherein I will configure all those 10 VLANs onto one switch, and that will relay or broadcast that configuration of 10 VLANs onto all the 50 switches. So that's the purpose of VLAN trunking protocol, VTP. What it does is, whatever I configure the VLANs on my VTP server, VTP clients will automatically learn them using this VTP protocol, VLAN trunking protocol. Okay. So, and as best practices, we should not use this VLAN 1 for our actual production ports. Right? VLAN 1002 to VLAN 1005, these are reserved VLANs. Some are for token ring or the old protocols FDDI. These are reserved ones. Cannot be deleted, but can be manually pruned from the trunks. Okay, they cannot be pruned via VTP, and they should also not be used since they are reserved VLANs. Okay, if we talk about extended VLANs range from 1006 onwards and go till 4094. Okay, in total, we generally said that we can have 4K or 4094 VLANs. These are not normal VLANs, these are extended VLANs. VTP, if we are using VTP in a transparent mode, there are 3 modes in VTP: server, client, and transparent. Server can configure the VLANs only on only a switch which is acting as a VTP server. Then only we can configure the VLANs or add the VLANs over there. Client can only learn the VLANs from a server. Transparent will act as a standalone. If a switch is acting in a VTP transparent mode, that will be acting as a standalone switch. I mean, we'll have to configure the VLANs over it, but it can relay the VLANs information. For example, between a server and a client, there is a transparent mode switch. It can relay whatever it has learned from the server towards the client. Okay, so these VLANs can be used using VTP version 3. Okay, out of this extended VLAN range, there are certain reserved VLANs for internal usage also. Okay, for example, when we configure switch layer 3 switch ports on a switch, that also consumes some VLANs, and we can when we log into our layer 3 switch, we will see also using this command, show VLAN internal usage. It will show you that VLAN is being used. Okay. But these VLAN usage, it is different for different switches. For example, in iOS switches, it is different, this internal VLAN. In Nexus switches, it is different. So it's better for your real deployment. You should verify in your configuration guides, whichever is applicable for Nexus and whichever is applicable for iOS. Any question, guys? Okay.
Hello.
Yes.
Sir, what is the FTDI VLAN?
These are some of the reserved VLANs. I mean, token ring is an old technology which was used. FTDI is for some fiber related things which were used, but nowadays they are not being used. Okay. If I show you over here, let's say this is the switch we are having. If you see show VLAN internal usage, as of now it is not showing anything to you, but let's say show the status, and on one of the port, let's say E0 by 2, 0 by 2, shut IP address. If I configure an IP address over here, I'll have to give a no switch port command. Okay, and let's say I configure not 1. Show internal usage. See, VLAN 1006 has been assigned and being used on this port. Okay, so that's what I mean to say about these internal VLANs. Let's come back. Okay, how a VLAN can be created on a switch. So in order to create a VLAN, there can be several methods. For example, globally, we can define. I can configure it globally, VLAN, and then I can give a number, VLAN ID over here. Okay, or if I go to my VLAN database, it's not over here. Otherwise, we can learn that directly into my VLAN database. This VLAN information is always stored in a VLAN database. Or if I go directly onto a port, let's say this one, switch port access VLAN. If I configure over here, let's say VLAN 30, so it will also create. I mean, VLAN does not exist as of now, but it is creating that VLAN. Okay, so VLAN can be created globally or directly into the VLAN database, or at the time of assignment to a port, it can be created. What it means is, while after creating a VLAN, there is a spanning tree instance also created automatically, and a corresponding MAC table is also created for that VLAN. Show MAC address table VLAN 30. So this is MAC table corresponding to VLAN 30. Okay. Similarly, spanning tree we will cover in detail. I'll just show you. VLAN 30 is having a separate spanning tree instance. Okay, that we can go. Or if I want to see what all VLANs are configured, there are commands, show VLAN brief. It will display all the VLANs that has been configured. VLAN 1, 10, 20, 30, what all ports have been configured in that one. By default, all the ports, as I said, are part of VLAN 1. E0 by 1 we have specifically configured in VLAN 30. VLAN 10 and 20 are separate. We configured that. Okay, this is the same thing what we have right now covered. We can define a VLAN. We can also define a name to that VLAN. That is just like a description to a port. Okay. So, okay. So in our switch, there are on a high level two types of ports. One is access, one is a trunk port. So what is the difference between an access and a trunk port? Can anybody tell me?
Access port is belong to a single VLAN, and
okay.
Trunk port, switch port that carry multiple VLAN traffic.
All right. Any other difference?
Access can be used for the point to point, and trunk for point to multi-point.
Trunk for point to multi-point.
At trunk point, multiple VLANs can be configured, and services will be multiple. nodes.
Okay.
Yeah, point
Okay.
one.
Fine. So let's say on a trunk port, how we are doing is we can define multiple VLANs. I mean, I want to pass on traffic for multiple VLANs, so that will be acting as my trunk port. However, on access port, any traffic leaving that access port will not have any VLAN tag onto it. Okay, I'll strip off the VLAN information from that Ethernet frame, and then I will send that frame towards the receiving device.
Access port is also on that port.
Access port, yeah. Access port, all traffic leaving that access port will be untagged. Okay, trunking, let's say we cover. For example, there are two switches, okay, and each switch is having these three VLANs, green, red, and blue, and having one host in each VLAN on each switch. So if you want to, let's say, keep them separate, and I want green VLAN host on the left side should communicate with the green VLAN host on the right hand side. I'll have, otherwise, if there is no concept of trunk, I'll have to put three different access ports connected over here. First link in the access VLAN green, second in the access VLAN red, third in the blue VLAN. Okay, that's where we are wasting this infra. Okay, now using the trunks, what we can do is we can use the same link to pass on the data of all the VLANs, but in order to send that data, what I need to do is I'll have to add some tagging or some information to the frames to make the other party know to which VLAN this port or this frame belongs to. For example, this green host is sending some data. So to that data, while sending that data from this port, okay, I'll have to tag that data. So we will have to add that information within that tag about this VLAN. Okay. On the next side also, what it will do is it will strip off that VLAN information while before sending it towards that access port. So in order to have that tagging information, I mean, there should be some protocol. If I am putting some encapsulation or tagging information, the other switch should also know, okay, this is the format in which I will be receiving the data, and that's how I need to decapsulate that. So that protocols are either 802.1q or also known as .1q trunking mechanism or ISL. ISL was Cisco proprietary mechanism. Nowadays, only .1q is being used. ISL is no more being used. Okay, these are the two dynamic protocols of trunking. However, there can be a static protocol also, wherein we are statically defining it as a trunk port. By default, my trunk, if I define it as a switch port mode trunk, it will be in a, by default, it is using a dynamic trunking protocol, which is DTP, automatically enabled on some platforms. So within DTP, if I talk about, there can be two modes. One is desirable, one is auto mode. And that's how they are configured. So desirable means that I will initiate the trunking negotiation. I will send some negotiation packets with the other side, okay, that I want to negotiate trunking information with yourself. And the other
actively trying to form a
yeah. Okay, that's why I'm eagerly sending those DTP packets. On the other side, if it has been configured as an auto mode, that is passively listening. Okay, so if someone is actively initiating the DTP negotiation and the other side is in an auto mode or passively listening, they will form a DTP trunking. But if the both are passively trying to listen, in that scenario, trunking will not be formed. Okay, so this table, what it shows is, let's say, as of now, if we consider this dynamic auto and dynamic desirable, okay, And in DTP, both sides.
Let me sir for port in dynamic auto mode, not trying to form trunk. They only form if the other wants to form.
Correct. If any one of them, I mean, let's say this one, this one is, one side is saying dynamic desirable, other is saying auto, it will form a trunk. If in this one side is saying dynamic auto, other one is saying dynamic desirable, then the trunk will form. Both are saying dynamic desirable, trunk will form. But if both are just trying to listen and do not send anything, the port will be in an access mode. Right. Similarly, if I am manually defining it as a trunk, both sides, manually defining trunk, it will be a trunk. On one side, we are defining it as access. On the other side, we define it as trunk. There won't be any trunking. Okay. Both sides defined as trunk will form a trunk. Or on one side, it is auto, and other side, it is manually trunking, then also the trunk will form.
Gaurav, what exactly you meant by limited?
Limited means, I mean, one side it is saying that I'm an access port. So access port means I will send data as a untagged packet. Okay. But on the other side, it is saying I'm a trunk. So what I'm expecting is, I'm expecting every frame what is coming to me would have a VLAN tag.
Right.
Okay, that won't work. Basically, packets won't, I mean, one is sending the packet, other one is not able to decapsulate or receive them, will not be able to understand them.
Okay.
Why? Because the reason is same. On access port, I'll be sending a packet which is untagged. Other side, it is trunk. It will assume that any packet receiving on this trunk port would have a VLAN tag. If it is not having a VLAN tag, what it will do, it will consider it as a native VLAN packet.
Okay.
Or it may consider it as a native VLAN packet. Because native VLAN, I will assume that every packet which is coming in a native VLAN will be untagged.
Okay. Yeah.
Let's go to the other one. Okay, let's cover this one before moving to our lab. So how it happens is, this 8021Q, this is adding a tag within our source or what was our original frame. It is adding a tag into over here. Okay, how this tag is having is, it is a 4-byte tag, that is 32 bits it is having. Out of those 32 bits, 16 bits are defining the type, which is 0x8100. Always, I mean, this is the tag for the Ethernet. Priority bits is for QoS bits, 3 bits for defining the priority of the type of the frame. Okay. Flag is for the MAC address format. Canonical and non-canonical, there are two kind of format in order to designate that this is a flag bit. And the last one is most important, which is a VLAN ID. So VLAN ID is 12 bits. You remember we have VLANs from 0 or 1 to 4096 only, or 4094. Why that number only? I mean, why not more than 4094? The answer is
12,
over here.
12,
Okay,
2 to the power 12.
Yeah, because our tagging is only till 12 bits only. That's why that number is only 4094. I mean, sometimes this question is asked in the interview also. Okay. So this VLAN is being added. Okay, native VLAN concept I'll also cover over here. So by default, what is meant by native VLAN? Native VLAN do two things. On a trunk, any packet which belongs to my defined native VLAN, that frame will be carried over the trunk as untagged. Okay, no tag will be added to a native VLAN. For example, VLAN 1 is my default native VLAN. So any packet which is traveling or which is being sent for VLAN 1 over this trunk will not have that tag. Okay. Second thing is, my on this trunk port, both sides, my native VLAN should match. If there is a mismatch, it will generate the logs also. Okay. And if let's say on from one side I'm getting a untagged frame, what I will do is I will consider that frame as part of my native VLAN or VLAN 1. Okay, any questions on this native VLAN? Please mute yourself. Okay. So let's move to our lab again. Power of these devices. Right. Okay, let's try this one. Let's consider that these two hosts, VPC 9 or VPC 4, they are in VLAN 10. Next. And they are in VLAN 20. Okay, these below hosts are in VLAN 20. Let's configure this quickly. Okay, first what we'll do is we can configure a VLAN, let's say on switch 1 or it is switch 7, host name switch 7. We configure two VLANs, VLAN 10 and 20. Okay, two VLANs we have configured. Okay, put this port VLAN E0 by 1, switch port mode access, switch port access VLAN 10. So that's how we are configuring our access ports. Okay, by default, this every port in VLAN 1. On E0 by 2, what we will do is we will define define a switch port mode access, switch port access VLAN 20. Okay. And on this side, switch 8. Let's say I give it a switch 8, a name. Okay, and configure the 2 ports, E0 by 1. What I'm doing is I'm not manually configuring the VLANs. I'll just configure it on the port. It will automatically be added to the VLAN database. Switch port mode access, switch port access to VLAN 10. Okay, VLAN does not exist, creating VLAN 10. So it's E0 by 2 port, switch port mode access 20. Right now, how about interface E0 by 0? If I or let's say first, let us check the interface status. Show interface E0 by 1 switch port. This is the command to check the details about the switching interface. So let us see this thing. So on E0 by 1, switch port is enabled. That means this is a layer 2 port. But what is the administrative mode? Administrative mode is what we have configured using the command. What we have configured is we have given switch port mode access. It is in a static access mode. Operational mode is what it is, in which mode it is operating. Although we have configured in an access mode, and it is also being operating in a access mode. Trunking, if you see, administrative trunking encapsulation, it is saying negotiate. So it is still sending on receiving the DTP negotiation packets. So DTP, when we DTP is a dynamic trunking protocol, which is by default enabled on all the ports. Okay, so in order to disable that DTP over here, we need to give a switch port no negotiate command. Okay, operational trunking encapsulation, DTP is same what we talk about, desirable and auto modes. That is dynamic trunking protocol. Okay, operational trunking encapsulation, this is only trunking the native VLAN. Or it's not, I mean, it's not working as a trunk because its operational mode is access as of now. Okay, access mode VLAN is VLAN 10 we have configured, right? Voice VLAN we have not configured anything, right? Similarly, if let's say we now configure our trunk ports E0 by 0. Okay, what we will do is switch port trunk or
mode
trunk. It should not take before we define the encapsulation. Okay, so switch port trunk encapsulation we'll have to define either .1q or negotiate. Let's say we define .1q over here, right? On the other side here, now I can able to give a switch port mode trunk. On the other side, interface E0 by 0, switch port trunk encapsulation .1q we have defined. So what we are doing is we have just statically configured it as a .1q trunk between these two. We have not defined any of the VLANs. So by default, all the VLANs are being allowed on this trunk port. Okay, if you can see like they show run all run interface E0 by 0, all is not there. Okay, this is E0 by 0. If I see the status of this port, show interface E0 by 0, switch port see what's the difference. So administrative mode is dynamic auto, operational mode is trunk. Okay, administrative trunking .1 queue has been configured. Okay, and other thing is what I want to show you is, yeah, this one, trunking VLANs enabled. All the VLANs are being trunked over here. We can manually prune also on this trunk. First, let's see, let's try whether they are communicating or not. So we'll have to configure the IP address over here. On VPC4, let's say we configure 10.0.0.4.24. Okay. On VPC9, let's say we configure let us choose a different subnet. Sorry, 20 it should be. Okay, so from our VPC, this is the one. I've logged into this VPC4 host. Do we have any host command? I should change. We do not have. Set PC name is there. Okay, now it is fine. Okay, let's say I try to ping this one. Yeah, it is reachable. But will I be able to communicate with any device from 20 network? Then no gateway found. Okay, because I do not have, I have not configured any gateway onto these devices. Neither I have configured any layer 3 port onto these switches. So that's why it is not communicating. If I configure a gateway over here on this switch and a default gateway in my host, then only it will be able to communicate. Okay, another thing, let's see on this switch, show run interface E0 by 0. If I configure, I mean, switch port trunk, what all options do we have? We have an option to allow or only certain VLANs. Okay, we can configure allowed VLAN. We can give a VLAN ID. We can add. We can give all. Okay, except or none. We can remove anything. Okay, that's what we can do. There is a case over here when we put this, for example, switch port trunk allowed VLAN. Let's say already these two VLANs are being allowed. Okay, and I want to let me on this switch port trunk allowed VLANs 10, 20. I have allowed these two VLANs, right? And if I see over here, so these two VLANs are allowed over here. Let's say in our maintenance window, I want to allow. Let's say in my maintenance window, I want to add another VLAN over here. So there, I mean, people generally do such kind of mistake. Okay, allowed VLAN. Let's say I give 30. So what it will do is it will override these VLANs. Okay, do you understand what I mean to say?
So, Gaurav, it will allowed only 30, yes?
Yes, it will overwrite what was allowed earlier with this 30. So it's better. I mean, it's as a best practice. What should we do is either use add option, switch port trunk allowed VLAN 30. There is an option. There was an option to add. Okay, but this add sometimes we miss. I mean, anybody can miss, and it can create incidents. So generally, as a best practice, what we should do is we should copy whatever is already there, paste it, copy, and then paste it here, then give comma and add your new VLAN over here. Okay. So to avoid any unnecessary incident with a switching network, it should be done like this, rather than just I mean, this add keyword, somebody may mistakenly, by mistake, he or she can omit. Otherwise, as a best practice, you should just copy whatever was there earlier, paste it, and then after giving comma, you can add your own new VLANs. That's what I mean to say. Okay, let's come back over here. Native VLAN, how we can define is switch port trunk native VLAN. That's how you can change your native VLAN. By default, it is VLAN 1, but you can change it also. Okay, show interfaces trunk also. So if there are multiple trunks, we can see like this also. Show interfaces trunk, it will show you the port which is in a trunk mode. What is the encapsulation it is using? What is the native VLAN? How many VLANs it is allowing? Okay, and out of these 3 VLANs, you can easily see that only 2 VLANs are part of our VLAN database. Third VLAN, there is no such VLAN on our switch. I mean, there is no access port in this VLAN, neither it has been configured. That's why spanning tree is for, and this is showing the spanning tree forwarding state of this port. Any questions till now for this trunking part?
Hello.
Yes.
Can we configure multiple VLAN on access port?
Only
is there any provision on 3650 switch?
No. I mean, it's not dependent upon the variant of the switch, but if you see, show an E, what was our port? E0 by 1, huh? E0 by 1. So if it is an access mode, one could be a data VLAN. In addition to that, you can configure a voice VLAN also.
Okay.
That we can do. Switch port access. There is an option. Or switch port voice. Yeah.
So only 2 VLAN we can add in the
2 VLAN, but this is also a specific. I mean, this is for a specific use case. Voice VLAN is to connect your IP phones. You must have seen in some of the offices how we are connected. Is your LAN cable is coming from the switch, is going first to your IP phone, and from that IP phone there is another port which you guys use to connect your laptops or desktop.
For multicast data, can we configure access port for multiple VLAN?
Say again, sorry.
For multicast data.
Multicast VLAN.
Yes.
What is this multicast VLAN?
Multicast data, like stream data.
No, I mean VLAN is I mean normal VLAN is a for streaming a data, then also it will be a kind of VLAN only. I mean, out of these 124094 VLAN IDs, we would designate one of the VLAN as a VLAN or a broadcast domain, which will be carrying your streaming data. However, it is a normal VLAN. It's a part of either your normal VLAN or an extended VLAN. But as on a switch port, you can only configure these 2 VLANs on an access port. One is a data VLAN, one a voice VLAN. No other VLAN cannot be configured. Let's say if I try to configure. Earlier, what it is configured? It is configured in VLAN 10. If I configure any other VLAN, it will be overwritten. If I configure 20, it will be overwritten. I do not have any option to add that VLAN.
Okay.
Because otherwise your purpose will be defeated. Na? Right. Since this is an access port, you want purposely you are configuring it as an access so that your packets can be sent as an untagged over this port.
Yes.
There will be only one person who will be receiving this.
Yes.
All right.
Okay. Thank you.
Sir, can we know one port is trunk and another is at the trunk port?
Sorry, can you ask again, please? What is the question?
And we have connected trunk port.
No, your voice is breaking. I'm not sure if it is only for me.
Accurate configuration. And what which element you have received at the port?
You have to repeat your question, guys. I'm not able to hear it completely.
One is connected to access and another is connected to trunk. Okay.
Okay.
And currently I'm available at trunk port. How we can define another port is checking the connectivity.
Sorry, man. Your voice is cracking a lot.
Sudhir, your voice is not audible. I think you'll just write a message in the chat.
Gaurav.
Yes.
I have a doubt. Suppose in our network we are using the lots of IPTV. Okay, for the streaming.
Okay.
Yeah. Okay. So this IPTV, which VLAN we have to configure in this all IPTVs? It should be in the normal VLAN.
I mean, it does not matter from
You
from
can
a
create a
switch.
multimedia.
Yeah, from a switch perspective, it's just a VLAN is just you are segregating that traffic. For your multicast traffic, how it happens is, for example, there is a concept of receiver and a listener and a sender in your multicast. One of the host will be sending that data and or streaming that data, and there can be multiple hosts who want to subscribe or who want to receive that data. Irrespective, I mean, they all, my receivers and senders, if it is a switched network, they all should be part of same VLAN.
Okay.
Okay, but I mean, if any router is coming in between, then we need to run some multicast protocols like PIM and IGMP on the LAN side in order to know, or in order to agree on that information, that which where is my sender, where is my receiver, on which multicast IP addresses or groups I should receive the data. That is the purpose of IGMP and PIM protocols. Okay, question from Sudhir. Sir,
Sir, what is this native VLAN, like native VLAN one you just mentioned?
Okay, I think he is asking, on one side it is access and one side it is trunk, which alarm we receive at the trunk port. Okay, we can try this thing. No issues. E050. This is trunk. Let me configure it as access. I'm not getting any logs. I mean, on one side it is access, one side it is trunk. It is not going to show me any logs. Logs will come. Okay, it is showing inconsistent ports because of your spanning tree BPD only. Okay. Otherwise, what we spoke about is, if let's say on one side my native VLAN is different, on another side my native VLAN is different, then only it will send me a continuous logs will come. I'll show you that thing. Okay. Let me remove this thing.
Sir, at switch port, if switch is unmanaged, then how we can define then at the port for management and other alarms? What is the issue at the port?
If a switch is unmanaged,
yes.
If a switch is unmanaged, you cannot configure it. You won't be able to
No.
configure
How can define the which port have the issue? Actually, management is got, but connectivity available there.
So in that case, it will goes to native LAN.
No. What do you mean by a switch is unmanaged? Does that mean that you do not have
MAC address
management?
is not available. Yes, MAC address is not available, but connectivity is available.
People who are
One
not
is a
talking,
trunk
can
and
go on
another
mute.
is access.
No. Wait a minute. Okay. Let's say these are this is switch 1. Okay, and this is switch 2. Your question is, on one side you have configured it as trunk, on other side you have configured it as access. Is that so?
Is that minimum 2 VLAN we can configure, but when we more than 2 VLAN we configure, which VLAN we have found, and how we can define the issue as which port is available?
No. What is your scenario?
About the log we.
Can you please repeat? What is your...
Sir, I have just 2 questions about which log we have available at the trunk port, and second is, if my second router is unmanaged, then how we can define the port is
what
trunk or access?
What exactly do you mean by unmanaged? Does that mean that this is does not have any login capability at all? Because there are switches.
Yes. Actually, MAC address is not available, but connectivity is available. My data is working, but MAC address is not available at the router, at the switch port.
No. You are mixing multiple concepts over here.
No, Gaurav, he is telling the MAC address is not showing. So how he knows MAC address is not showing if he cannot log in the switch?
Whose MAC address?
He is telling
router's MAC address. Second router, MAC address is not available at the first router. Okay.
These are switches.
But connectivity is available there.
Are these
Actually, we have
switches?
connected 2 pairs.
No. These are switches or these are routers?
We're reading the switch, like MAC router.
Switches. Only switches.
Okay. Then which MAC are you talking about?
If second switch MAC address is not available, but connectivity is available, and port is connected to trunk and access, then how we can define the port issue is configuration issue, or cable connectivity issue, or VLAN issue? How we can define them?
No.
And troubleshooting.
Can people who are not talking please go on mute? I'm muting all. Please, the person who is asking the question, please unmute himself. Yes, please. The person who was asking the question, can you please unmute yourself and explain?
Yes, sir. Actually, I have 2 switches, and I am connectivity available, and first switch first, and the second is unmanaged, but the connectivity is available there.
Okay, wait. Let me clarify. Unmanaged means what? You do not have access,
actually,
or it is unconfigurable? Because actually, there are switches in the market.
We are not reachable second switch, but
okay, you cannot reach it.
Flowing.
You cannot reach it. Huh?
Yeah.
Okay.
Yes, sir.
But this is configurable. If you have access to this switch, we can configure this port. I mean, this switch is capable.
No. Sir, switch 1 is available switch 2 is not available, configurable, but our data is flowing.
If
MAC
you
address is not available only.
if you manually go to this site where switch 2 is installed and using the console cable, will you be able to configure the switch 2 or not?
When we be manual there, we can configure, but I am currently available at switch 1.
Okay, so that means it is manageable switch, but somehow management is not available to you guys as of now, right?
Garo,
Yes,
let's
sir.
Pawan is there. Let's Pawan is there. Pawan can clear it.
Gaurav, it's a simple, Gaurav. Exactly what you're saying, that is correct. One is managed and one is unmanaged. What he's asking is just he wanted to know that whether it will communicate or it will learn the MAC or not. That's it, his question. He's a bit confused. Sudhir, you can ask in Hindi also, no? It would be better for you.
I can, yeah, at least I can understand, yeah.
Yeah.
सर मेरे पास 2 स्विचेज है, मैंने मतलब कनेक्टिविटी कर रखी है,
ठीक है,
और मेरा जो सेकंड स्विच है, मेरे जो पोर्ट से 1 स्विच के पोर्ट से कनेक्टेड है, उससे मैनेजमेंट नहीं है, बट कनेक्टिविटी है, हमारा डेटा फ्लो हो रहा है,
ठीक है,
जो मैनेजमेंट हमारा है वो अदर पाथ से आ रहा है, वो हमारा डिस्कनेक्ट हो गया है, तो मेरा सेकंड जो स्विच होगा वो अनमैनेज हो जाएगा, बट मेरा जो डेटा फ्लो होता रहता है
राइट
प्रोडक्शन पाथ से,
ठीक है,
तो हम कैसे सर डिफाइन करेंगे कि जो है वो किस नोड पे इशू आ रहा है?
नहीं, इशू क्या है यहाँ पे? आई मीन फ्रॉम दिस स्विच you can check the status of this port.
सर मेरा डेटा तो फ्लो हो रहा है, मेरा मैनेज नहीं हो रहा है स्विच, मेरा जो स्विच है वो मैनेज नहीं हो पा रहा है, उसको मुझे मैनेज करना है।
तो मैनेज करने के लिए you have other path. You already said it is managed via a different path. It is not being managed via this path. For example, आपने यहाँ पे एक मैनेजमेंट VLAN करके कॉन्फ़िगर किया है, which is VLAN 10.
नहीं सर, मेरा जो प्रॉब्लम है, मैं एक बार फेस किया था, मैं फील्ड में था, मेरा क्या हुआ कि मेरा जो सेकंड स्विच था वो स्विच अनमैनेज हो गया, पहली बात। दूसरा बंदा, एक मैं न्यू बंदा गया हुआ था वो, और उसने उस पोर्ट को चेंज कर दिया, एक्सेस में डाल दिया, ठीक है। मैं ट्रंक वाले पोर्ट पे स्विच 1 पे था, तो मैं परेशान हो गया, उसको कैसे उसमें क्या कर रखा है।
For that purpose, Sudhir, you have to define, I mean, you have to clarify how your switch is being managed. Usually, how it happens is, हम एक ना define करते हैं management VLAN, dedicated management VLAN रहता है मेरा. For example, VLAN 10 is there. Okay. For that VLAN 10, I will define a layer 3 SVI port over here, and उसको I will give an IP address. And that VLAN 10, which is my management VLAN, that is also being trunked over here. Agar if I want to manage using this trunk only, that's how I will do that. Otherwise, अगर मेरे पास out of band connectivity है या there is another path on which I am passing this management VLAN, then it will be a different scenario altogether. But I think आप ये बोल रहे हैं कि मेरी management was there from a different path and that somehow went away. I do not have management to that port. And आपने क्या किया कि इसको इस पोर्ट को चेंज किया या इसका कॉन्फ़िगरेशन को चेंज किया, ट्रंक से आपने उसको एक्सेस बना दिया, एंड दैट्स हाउ यू वर एबल टू रीगेन द मैनेजमेंट ऑफ दैट स्विच.
उस समय सर मेरा 2 VLAN चलने लगा, बाकी डाउन हो गए, बट अवेलेबल तो आइडेंटिफाई करो कि क्या
वो, हाँ, वो दैट इज case specific. Unless until we won't know, I mean, what was the configuration, we won't be able to explain over here that what was the issue, how it came to work, and मतलब 2 ही VLAN क्यों चल रहा था. We'll have to understand that.
VLAN ज्यादा थे, लेकिन जो ऐसे कॉन्फ़िगरेशन होता है, जैसे एक्सेस में आप कह रहे हैं कि 2 VLAN मैक्सिमम चलेगा, ठीक है, 2 VLAN
मैं 2 VLAN नहीं बोल रहा हूँ, मैं I'm saying 1 data VLAN. Along with that, I can only configure 1 voice VLAN. Voice VLAN is not my normal VLAN, that is separate. Yeah, on an access port, 1 data VLAN, 1 voice VLAN at max, not 2 data VLAN I can configure. But
actually sir, I was in Vodafone, and there was 3 services about 2G, 3G and 4G.
Okay.
And management.
Okay.
Total 4 VLAN is available there.
Okay.
And when my management VLAN got was up, but management not available there. Which port? got
so that
मेरा कहने का मतलब जो सेकंड पोर्ट था वहां पे बंदा ने पोर्ट को एक्सेस से ट्रंक से एक्सेस कर दिया और मैं इस पोर्ट पे सेकंड स्विच पे था। ये हो क्या रखा उस नोड पे कनेक्टिविटी अवेलेबल थी, पिंग भी मिल रहा था, बट चीजें कॉन्फ़िगर नहीं हो पा रही थी, सर्विसेज डाउन थी।
Alternate port console problem.
All right, maybe, I mean, so there it's very difficult to comment onto that scenario because we do not know completely उस टाइम पे क्या चीज था. Otherwise, if you think from a, I mean, शांति से आप अगर देखेंगे ना तो you will be able to easily troubleshoot because on a trunk port आपका जो भी frame जाएगा ना that will be tagged. On the other side, if it is an access port, I mean, it will not be able to, I mean, a tagged frame आया मेरे पास on an access port. Will I receive? नहीं करूंगा ना मैं उसको receive because I will expect that access port पे मेरे पास untagged packet ही आएगा, right? Similarly, access port से अगर मुझे बाहर कोई frame भेजना है, I will be sending only untagged packets. और on the other side, अगर मेरे पास कोई untagged frame receive हो रहा है, I will consider that frame as a part of my native VLAN. That's it. तो मेरे native VLAN में अगर कोई और host होगा, उसके साथ वो communicate कर लेगा, है ना? तो maybe आपका जो management वाला VLAN रहेगा ना, वो native VLAN का part होगा, शायद इसलिए आपका वो communicate कर गया होगा. So on one side it is trunk, one side it is access.
So sir, if we do not configure any VLAN, then there will be only native VLAN.
Where?
How is that? Where? In the switch. If we are not configuring any VLANs, then it will be only native VLAN. Means that the native VLAN will be always there in the switch.
VLAN 1 default always.
Yes.
Consider like this.
If any of the ports has not been assigned to any VLANs, then it will be automatically in the VLAN 1, right?
Correct. By default, all the switch ports are part of VLAN 1. VLAN 1 we do not need to configure. It is already there. Okay. And native VLAN concept only comes when we configure a trunk port on any trunk interface. If we have not configured specifically any native VLAN, that will be by default VLAN 1 will be my native VLAN. And all the packets of that VLAN, native VLAN, will be sent untagged.
Oh, okay, sir. Thank you.
Right.
Isn't it trunking port we use for the connect with another switch?
Say again.
Isn't it a trunking port we connect with another switch?
Yes. Sorry, maybe I didn't get your question. You're saying switch to switch connecting port will be a trunk or so? Huh?
Yes, that's my question.
Yes, usually it is, depending upon your use case. For example, if I go back onto our slides, we saw this one. Let's say switch to switch, this one. Switch to switch. If I want to pass data of multiple VLANs, by default, these ports are in an access, or if I configure them as an access port, only one VLAN traffic can be passed over here. So for 3 VLANs, I should have 3 different ports.
So we can have ether channels then?
No, ether channel will be bundling them together. Ether channel purpose is different. We'll cover them in our next class. Ether channel is to bundle the bandwidth of multiple or multiple links together. Its purpose is different. I mean, here we are talking about either the port is access or a port is trunk. Access will be sending the data untagged. Trunk is used to carry the frames of different VLANs as colored or tagged packets, you can say.
Can you explain the difference between native and default VLAN?
A native and default VLAN. Okay. Default VLAN is VLAN 1 always. but native VLAN can be changed. If you see like this, okay, and I can configure on this trunk port any switch port trunk native VLAN. I can configure any of the VLAN as a native VLAN. Let's say VLAN 30, I configure as a native VLAN. So what does that mean is, any untagged packet, if I receive on this port, I will consider that packet as part of VLAN 30. Or any VLAN 30 traffic, if I want to send towards this E0 port, out of this E0 port, I will send that as untagged. It's both ways. Outgoing packet for this VLAN will be sent as untagged native VLAN. See, this was the log which I was telling about. If a native VLAN mismatch between the two trunk ports of the switch, this kind of log it will give. Are you clear about this native VLAN, default VLAN concept?
Yeah.
सर ये डिफॉल्ट VLAN और नेटिव VLAN अगर हम लोग अलग अलग रखेंगे, सपोज 1 and 30, तो सेकेंड एंड स्विच पे कौन सा पोर्ट विद अनटैग्ड मिलेगा, कौन सा VLAN अनटैग्ड मिलेगा?
Okay, let me rephrase this thing. I think still people have some doubts. This is switch 1. मैंने नेटिव VLAN दोनों साइड पे, let's say we configure VLAN 30 as a native.
Right. And default VLAN is 1.
Default VLAN, forget about default VLAN. Default VLAN is nothing but a VLAN in which my ports are automatically there. I mean, without any configuration, all my ports will be in VLAN 1. That is always VLAN 1. I cannot change my default VLAN. Okay, but native VLAN I can change on trunk, and native VLAN is only significant on a trunk. That can be possible that there is another trunk between switch 1 and switch 3. Okay, and here my native VLAN is different. Let's say VLAN 50 is my native VLAN on this trunk port. This may happen.
Okay.
Okay. Now, any packet which is leaving from switch 2 towards switch 1 on this trunk interface. Okay, and that packet belongs to, let's say, here is a host which is in VLAN 30. This is access port VLAN 30. So the frames which this host 1 is generating, and let's say this is another host 2. This is also in VLAN 30. So while sending these packets of VLAN 30, will they be tagged on this trunk port? No. Why? Because I have specifically defined VLAN 30 as my native VLAN.
Okay.
Okay, they won't be tagged.
So native VLAN is configured on trunk port.
Trunk ports, yes. Only
Not
trunk
on
port. Not on the switch. No. It is configured on your trunk port only.
Okay.
On that interface, specific to this interface. That's why I said that there can be, I mean, this native VLAN is trunk specific. On this trunk, it is VLAN 30. On this trunk, it can be VLAN 50 also.
Correct. Got it, sir. Thank you.
All right.
Yes. Got it.
Any other question, guys, on this trunking? I would appreciate if, your questions are very good, and it's better than that you guys are clarifying your doubts over here itself, because otherwise these are the basic things what we are doing of switching, and later on it may create a problem. And it will be great if you guys can, before coming to the next class, if you revise all these concepts and you can note down your questions if you still have. We can go through those in our next class. If I come back to my slides, what is the next thing we are going to do? This one we did. VTP is, we'll go through some of the concepts. In a brief, I have covered, but yeah, VTP we will cover. Okay. Let's pause for today over here. All right. If we do not have any questions, we can stop our today's class. Last time, any other questions you guys have?
Yeah, Gaurav.
No, Gaurav.
Can you repeat DTP modes? Actually?
Okay, DTP, yeah, we can do. Trunking we covered. Okay. So DTP is nothing but a dynamic trunking protocol. It is automatically enabled. By default, it is enabled on our Cisco iOS switches. Okay. In DTP, we have two kind of ports. One is configured as dynamic desirable, and another one is configured as dynamic auto. If we see over here, so we have this thing. Let's see.
Gaurav, I think, but it is not the best practice in the real scenario. Yes.
Which
DTP?
one? No,
DTP?
DTP we do not use as a best practices. We disable DTP actually, and we
Yes.
manually configure either. I mean, normally 8.1q trunking is being configured.
Yeah. .1q is the open standard protocol. Yeah.
Open standard, yes, open standard. So if you
Okay.
talk about this one, that's how we can configure mode, dynamic, desirable. On one side, we can configure desirable. I mean, if let's say on both sides, it is configured as dynamic auto. So that is a passive listening kind of mode. Then your trunk will not succeed. Your trunk will not come up. Otherwise, if both are desirable or both side, it is either one side desirable, one side dynamic auto, then also your trunk will come up. Okay, in order to disable this one, or I can show you this thing now. If I, let's say, capture the packets on my trunk port, you will see DTP is being sent. See these DTP packets, dynamic trunking protocol. It is continuously sending this. Trunk status, value, auto. By default, it is in a auto mode. On one side, configured as auto. Let's say we configure it as trunk. These are the DTP packets. Search. Filter it. Trunk type value is negotiated because other side we have configured .1q. Okay. And if I want, see these DTP packets are still ongoing. Let's say I configure it as switch port trunk encapsulation .1q. I have configured manually, but still it will keep on sending DTP packets. I'll remove this one. So trunk. See, it's in a trunking status. Okay, and still it is sending the DTP packets. If I want to stop this one, what I need to do is switch port no negotiate is the command to stop these DTP packets. Config between no negotiate and dynamic status. Wait one. Switch port mode trunk also need to be given. So we have manually defined it as a trunk and given a no negotiate stuff. So there are two methods by which we can stop the DTP packets. This is being, in some of the exams, this question may come. Okay, if I want to stop the DTP messages on a port, either I can configure it as an access port, or I can configure this command, switch port no negotiate. These are the two methods. Is it clear? DTP, dynamic trunking protocol?
Yes.
Yes.
All right, guys. If no further questions, then good night for today.
And thanks, Gaurav, for sharing the knowledge.
Yeah, sure. Thank you.
Your class is very interesting.
Yeah, thank you, guys. Thank you. Thank you, everyone.
Thank you, everyone.
Yeah.
Bye-bye.
Bye.
Thank you, Gaurav.